How's it going? Hope you all are doing alright today. Sorry I'm running a little bit late. Just give me 1 second, please. Oops. I don't even know what I'm doing anymore. There we go. All right. I did get your tests all graded last night, so hopefully you saw that and we're okay with the outcome. Generally pretty good. I know several of you wanted to do better than you did, but not too bad overall. I don't know if anyone got 100, but several of you got close to 100, which is nice to see. I wanted to point out something on number 7 on the exam. Something that was somewhat confounding to a few of you, especially the ones that come very close to 100. This is like the only mistake that you made. I mean, look at these numbers here, 0, 2, and negative 4. Notice they're not in order. The negative 4 would actually come before the 0. So when you think, okay, cross, touch, touch, some of you drew the graph over here where it crossed and then touched and then touched. Now, again, negative 4 is actually first, so this one should touch. 0 should cross, and then 2 should touch. So, minor thing, but it's an important distinction that we need to make. The other biggest mistake I saw on the exam was on 14. A lot of you thought this was factorable right here, x squared minus 4x plus 5. And it initially appears to be. And actually, I had a question, I think it was number 2 on the test, where it was x squared minus 4x minus 5. And that was definitely factorable, but the plus here is what makes this not factorable, because we need two numbers that are both negative to match up with the signs here, that multiply to 5 and add to negative 4. And it turns out that's impossible. They can't both be negative and have that add up to a negative 4. So a lot of you thought it was one negative, one positive, which I could see where you got that. It was an unfortunate error, but the reality is that we can't factor that, so we have to use the quadratic formula to solve it. Don't really pay attention to what I did here. This is completing the square, which I prefer to do in certain cases, but it does come out to be a complex answer there. Anyway, so those are all graded, and if I haven't mentioned it recently, remember that your final exam will replace your lowest test grade. Uh, if your final exam is your lowest grade, it still has to count for itself, of course. But if it's also higher than one of your uh, previous exams, then it could replace that grade. So I certainly believe that, even if you've made some mistakes along the way, if you pull it together for the final and do better, I want to give you credit for doing that. So, speaking of the final, some of you had questions about how the online final would be given. The online final will be given through Canvas, through our Canvas course. Still not quite sure how the proctoring is going to work, because I emailed one of the other professors that's kind of managing that about it, and she answered all my questions except the one about proctoring and how they all are going to connect to that. So I'm waiting for her reply. If she happens to reply during class, I'll keep an eye on it. But otherwise, I'll make an announcement in the Canvas and let y'all know through there. So I apologize for not knowing more. All those decisions were made without me, so I'm kind of in the loop on this, unfortunately. Yes, the formula sheet is already part of the exam, so it's just a question of, do we upload, what version are you taking? Well, you get the printed version, and then the printed version is basically what's uploaded to Canvas and incorporated as a Canvas exam. So you'll have the same formulas either way, which should be the same formulas we've been looking at all along. So, yeah, I mean, this online proctoring is a great mystery. I don't know. And I can get the final exam ready, but I'm not going to publish it yet. Just to make sure everything's in order. Anyway, were there any questions on the review that we wanted to talk about, or from the book, or anything else? Let me bring up the review on my computer. Now, I do have a solution. I have a key written out to the final review that I made last fall, and I will upload that so you have all the answers. And I've tried to be as descriptive as possible in writing out the answer, as far as key indicators and things like that. But I just wanted to spend this time today. If there are specific questions, August is on top of it here. Then we can go over those. So I guess I'll use that as a jumping off point. 1, 2, 3, 4, 13, 14, 16, 22, 24. I don't know if we have time for all 25. That's my my worry. But like I said, I will upload my key to the review. That way you can look at all of my solutions to everything, and hopefully that's descriptive enough. If you still have questions, you're welcome to email me prior to taking the exam. So, let's see. Number 1. I'm going to write down the function first, and then I'll center it on the screen. Oh, okay, I got it. So we want to sketch the graph of this function using the vertex and the intercepts. And it says axis of symmetry. I'm not going to worry as much about the axis of symmetry. Yeah, Amanda, if you want to go ahead and list those out, that's fine. And that may get us through the whole class. Yeah, so for the vertex, we use the negative b over 2a. Which is negative 6. A is 1, so we divide by 2, so x is negative 3. And for the y value, we take that negative 3 that we just got, plug it into our equation for x. So negative 3 squared is 9. 6 times negative 3 is negative 18. And then plus 5, so that would be negative 4. So our vertex is negative 3, comma, negative 4. Now the intercepts, first of all, for x, we set the entire expression equal to 0. And this problem should be factorable. I don't know why we wouldn't make this a factorable expression. I completely expect that to happen on the final. If I remember right, it is. We're not trying to make you use the quadratic formula at this point. But we need two numbers to multiply to 5 and add up to 6. So that is 5 and 1. And so we get x equals negative 5 and x equals negative 1. So our intercepts are negative 5, 0 and negative 1, 0. Some of you might have noticed on number 2 on the test that I just graded. I went back and looked at your number 2 because some of you, instead of writing the coordinate, which is what I had set up to grade, the coordinate, if you just wrote like x equals negative 5 rather than negative 5 comma 0, I went back in and gave you those points. So it's not a perfect grading tool, but it does eliminate a lot. It does help me have less to look at going through the grading process. Alright, and then our y-intercept, we just plug in f of 0, which is 0 plus 0 plus 5, so 0 comma 5. Now, plotting our points here, negative 3 comma negative 4. Negative 5 comma 0, negative 1 comma 0, and 0 comma 5. So our graph will look something like that. And it may be that this is a multiple choice question where you pick out like which graph best fits this function, and so you can find all these things and then match it up from there. Yeah. Number 2. F of x equals 4x squared minus 2x minus 3. Here we want to determine whether it has a maximum or a minimum and then find that value. So first of all, this one has a positive number in front of x squared. So that means the graph opens up. And because it opens up, that means we're going to have a minimum located at the vertex. Okay, so that's what that tells us. If this had been negative, then it would be less than 0, it would open down, and then the maximum would be at the vertex instead. So that's how we're determining minimum versus maximum. Guarantee you there's one of those on the exam. Because that's a very important aspect that we use mathematically in future classes, not just math, but also sciences and applied math. So, anyway, we still need to find the vertex. So x equals negative b over 2a. This is where it gets a little bit weird, because now we have to work with this fraction. X is 1/4. Now, if you prefer to make that decimal would certainly be easier to plug into this equation. If the exponent was an odd number, it basically wouldn't have a maximum or a minimum, because an odd if our leading term has an odd exponent, then it either goes up left and down right, or down left and up right. It goes to infinity both directions. So plug this in. So that's 4 times 0.25 squared minus 2 times 0.25 minus 3. 0.25 squared is 0.0625 minus 0.5 minus 3. This, when we multiply it by 4, that's 0.25. 0.25 minus 0.5 minus 3, so it's minus 3.25. And that is the minimum. Notice we're getting specifically the y value as the minimum, especially when you see that in this case where it's written with just one number rather than an ordered pair. It's always the y value that we want as the minimum or the maximum. Yeah, and it says the answer is negative 13 over 4, which is equivalent to negative 3.25. And honestly, that's how other people write. I didn't write these review questions. So someone else wrote them. I wouldn't do that, y'all, where I put the x value of the vertex as one solution and the y value as a different solution. I feel that's a little bit unfair to our students. That it's a misleading answer, in my opinion. I don't know how it's going to be on the exam. You might expect it to be similar on the exam. I wrote part of the exam, but not all of it, and it's been edited several times along the way. So. Okay. Next, number 3. Now this actually is related to what we talked about on Monday. It is a solution of a system of equations. Now, we talked about this particular type of problem briefly, but we looked at either the x's or the y's, and we want to get it to where we can cancel out one of them. Let's just use the x's. Now, if we want to cancel out the x's, what is a common multiple of 3 and 5 that we can use? So we look at that, so well, if we just multiply those together, 3 times 5, yeah, because it's 15. So we want one of them to be 15x. We want the other one to be negative 15x, so that when we add them together, it cancels out. Okay. So that means to make this into a 15, we'll have to multiply this first one by 5. And to make this into a negative 15, we'll multiply the second one by negative 3. It does look a little suspicious when we have both equal to 10, that it feels like it might be inconsistent, but in reality, I don't think it's inconsistent. Well, I guess we'll find out here in a second. Make sure I multiply these right. Okay. And then we add these together. The x's cancel out as planned. If we combine the y's, 20 minus 15 is 5y. And 15 minus 30 is 20. So that means that y is equal to 4. So we get y equals 4. And now we need to figure out what x is. So we come back, we can pick any of these equations, but I'm going to use the first one here, 3x plus 4y equals 10. We know that y is 4, so 4 times 4 is 16. Subtract our 16 over. So 3x is negative 6. And then divide by the 3, so x is negative 2. So we get negative 2 comma 4. Okay. And that point, or that coordinate, is the solution of both equations, basically the point of intersection of the graphs. Okay. Now 4, we definitely did not cover that, so you can skip 4. If it happens to be on the final, then I'll just give you the points for it. No, you don't have to use matrices there. It says to use matrices, but again, keep in mind, I'm the one grading this, and that's one way we can work that problem. That's how we looked at how to do that on Monday. So yeah, we can definitely do it that way instead if that's what we know to do. All right. Sure. It'll take me a second to figure that one out, but really all it is on number 4 is if we basically switch the x and the y, and then we solve for y. So 3x or 3y plus 4 equals 7 over x. 3xy plus 4x equals 7. 3xy equals 7 minus 4x. So y will equal 7 minus 4x over 3x. So it'd be C. This is review, Jessica. Anyway, you don't have to worry about number 4. We did not cover section 6.1, mainly through the interest of time. 6.1 and 6.2, I forget what that was part of, but yeah. Okay, 13 was the next one that we wanted to look at. Now, we didn't talk about 13, but I think we certainly have learned enough to do that problem. We'll see how it goes. The size p of a smaller herbivore population at time t in years obeys the function p of t is equal to 900 times e to the 0.15 t. If they have enough food and the predator population stays constant, after how many years will the population reach 2700? So the population is 2700. We want to solve this equation for t. So we didn't work anything specifically like this, but I think we have learned enough about exponents and logarithms that we'll be able to handle this if it comes up. If we divide by 900 first, because we don't want any numbers in front of our exponential, we divide everything by 900. That will give us 3 equals e to the 0.15t. Now this one, it actually makes more sense to convert to logarithmic form. So when we convert that, this is, we think about it as x equals b to the y. That becomes y equals log base b of x. That's our conversion formula right there. And so here's x, here's b, here's y. So we'll say 0.15t is equal to log base 3 of, log base e of 3. Now log base e of 3, that actually has another way that we can write it. Is log base e, remember, is natural log, so that's the natural log of 3. And then we can divide by 0.15. So natural log of 3 divided by 0.15. That gets t by itself, but now we need to approximate natural log 3 divided by 0.15. We take natural log 3 divided by 0.15. And so it gives us a value 7.324 years. If you look at the answers, should have our answer there. Yeah, answer A, 7.32. So while we didn't really work any word problems with, the conversion formula will be provided. While we didn't work with any word problems with exponentials and logarithms specifically, I think it's within the realm of our capabilities to be able to address those if any arise. So. Okay. Now 14 is pretty rough, not gonna lie. It's not in a multiple choice question, there's not a lot of great ways we can test for graphing. This is one way. We have two vertical asymptotes, -2 and at 3. And the y-axis is the horizontal asymptote. So fill in the graph here. Actually, it looks like it goes through this coordinate 2 right here. That should be helpful. And then up here. So, let me make sure I'm on screen. Okay. So we have two coordinates. It looks like we have 0, 1/2. It looks like it goes about halfway between 0 and 1. And it looks like we have 2, 0 is also a point on this graph. Vertical asymptotes are at x equals -2, x equals 3. And a horizontal asymptote is at y equals 0. Now, we have this information, and then we go back to the review, and we look at the answers that they give us. And at this point, it's really a process of elimination. First thing I would look for is to make sure that the vertical asymptotes are correct, that x equals -2 and x equals 3 are the solutions to the denominators. So looking at that, it looks like we can cross out C. So we basically have 4 answers here, A, B, C, and D. Now C, if you look at that formula, is x minus 2 and x plus 3 on the denominator. So its vertical asymptotes will be x equals +2 and x equals -3, opposite of what we have here. So we can eliminate C based on that. Let's see, as far as 2, 0 being a point in the graph, in each of the 3 remaining answers, A, B, and D, plugging in x equals 2 does result in the 0 because it makes the denominator 0 for each of the 3 answers, so that doesn't really help us anymore. I think what's going to be most helpful here is the 0, 1/2. Because all of these have the 2, 0, all of them have a horizontal asymptote, and all of the remaining 3 have the correct vertical asymptotes. So this is the last clue that we have, that it goes across the y-axis about halfway between 0 and 1. So for A, f of 0, looks like we get -2 on the numerator, and then 4 times 9 on the denominator, so -2 over 36, -1 over 18. We should get 1/2. Keep that in mind. I think we can rule out A because of that. For B, if you plug in 0 for x, we get 2 on the numerator and -6 on the denominator. So it's -1/3. Now, we have a positive number, not a negative, so I think we can rule out B, so it's probably going to be D. Let's just verify that with f of 0. Plug in 0, we get -2 on top and -6 on the bottom, which gives us a positive 1/3. So it's not actually 1/2, it's a 1/3, but the fact is that it's positive because it goes above the origin, not below like the other two would. And that's probably the most important aspect here. That's why we will safely choose answer D in this scenario. But that's also what makes this really difficult. Outside of our asymptotes, we really only have our intercepts that we can potentially work with. So that's what I would recommend looking at. If the asymptotes don't hold true, if they don't eliminate enough answers, we can look at the intercepts instead for the way that this problem is written. F of x is equal to 1 if -3 is less than or equal to x is less than 3. I believe so. I'm not quite sure if those are included on the formula sheet. They have been on the past, but I don't know if we include them now. I can say that we're probably not going to have a slanted asymptote. So if you want to focus on learning the difference in the horizontal, then that would be a good thing to focus on. Okay. So for 16, we're given a piecewise defined function. So f of x is equal to one of these three expressions, depending on which of these scenarios is true. And we're wanting to find out the value of f of 4. Now when they tell us to find f of 4, that means we need to figure out which of these three intervals is 4 part of. Is 4 between -3 and 3? Is it between 3 and 5? Or is it between 5 and 12? Well, we know that 4 is between 3 and 5, so we can use f of x equals absolute value of x. And so we plug f of 4 into that. So the absolute value of 4 is just 4. And that's really all there is to that. But the key has a graph. Don't worry about the graph. It's weird that they put a graph in that. Yeah, I really hope this one. Yeah, I really hope this one goes well. It's nice to have some that are just really short and hopefully understandable. It's not a lot of work to this. We just got to figure out which one it goes into and plug it in. Wow, that's a crazy answer. Let me look at that. 16? Yeah. It may be that they changed the question at some point from graphing a piecewise function to evaluating the piecewise function. But they didn't change the answer at the end. It could be that. Otherwise, I don't have any ideas. So. All right. 22. This is going to be a new sheet, or a new side of the page here. '22 gives us a graph, and we have certain points that are included here. A straight line, a loop, and curves down. Okay. Now, we're given 4 answers that include a variety of scenarios. Which essentially, they want us to determine the domain and range here. What else? Whether it's a function or not, and find the intercepts. It also mentions symmetry, but don't worry about symmetry. This one's not symmetric anyway. Now, when we look at the domain, remember the domain is horizontally all the x values that are included on the graph. Now, we have a solid dot here at this end, which means the graph simply stops at -2. But it keeps going to the right, and we have an arrow at the end, which means it continues in both directions. Our domain is from -2, but it does continue to infinity. Now range, we look at vertically, look at the y values for range. We know it goes down to -infinity. But we look at the highest point on this graph, it does not go past 0, does not go past the axis. So it's -infinity up to 0. Now that right there, let's see if that's enough to narrow down the answer. Now you'll notice, yeah, that is enough right there. You'll notice that one of them says domain and range are both all real numbers, which we know that's not true. So we can eliminate B. we do notice that instead of writing it as a interval, it's written as an inequality. So that's interesting. But yeah, this means x is everything to the right of -2, so x is greater than or equal to -2, and y is everything below 0, so y is less than or equal to 0. And that actually fits graph A right there, just based on the domain and range. We can safely eliminate D because this is definitely a function. And the reason we know it's a function is the vertical line test. Any vertical line that we draw on this graph only crosses the graph one time. If it crosses the graph more than once, basically if it loops back in on itself or as a circle or something, it's not a function. But this is a function, so we can eliminate D. Yeah, this is definitely answer A. They include the intercepts, but honestly, the intercepts are the same for A, B, and C. So it really doesn't distinguish anything in this answer. So it's really the domain and range that settles it, I think. Now 24, we did not cover 24. This is a matrix. Let me go ahead and write this down though, just to show you how easy this is. We're not actually solving the matrix, we're just converting it to a system of equations. Sure, Amanda. I think we do have time, but yeah. Okay. So we'll do 5 through 9, and 15, 17, and 18. We'll try to get as many or all of those if we can. Converting this, we think of each column as x, y, and z, and then equal to a number. So this is negative 9x plus 3y plus 5z equals negative 7. 2x plus 8y equals negative 2. 0 for z means we just don't put anything there. And then negative 8x minus 8z equals 3. So that appears to be C. Yeah, C. Anyway, if you don't get that one right, I'm not going to count it against you. But if you want to try it, it's actually not that bad once you see the pattern. Yeah, so I mean, even if you get it wrong, I'll count it as correct. So don't panic or really worry about that one. But yeah, it's not bad. All right, so let's go back to 5. Scroll up. Okay. So we want to find the difference quotient for this particular function, x squared plus 2x minus 3. And if you'll remember, when we first did this back in, I guess it was chapter 3, it did mention that we'd have 1 on the final. It's important for students that move forward into higher methods from algebra, so that's why we like to ask on the final. But no, that's not relevant to everyone necessarily, but that's what we do. Alright, now f of x is just going to be plugged in right here for f of x. H is just h, so really the only thing we need to find is f of x plus h. And then we'll build this thing up. That means everywhere that we have x, we're going to replace it with x plus h. So this x becomes x plus h, so squared, squared. 2x, x becomes x plus h, 2 still on the outside, but it has to now distribute, just like the square applies to the binomial rather than a single term. There's no x's over here, so nothing to change. So x plus h squared, if we FOIL that out, is x squared plus 2hx plus h squared. Then we get 2x plus 2h. And then minus 3. Yeah, the difference quotient, we usually just ask a square, like an x squared equation for a difference quotient. In calculus, we do a lot more beyond that, but that is calculus after all. But for this point, we just want to get you all used to working with this equation and just working with this type of substitution, like plugging in this binomial for a single value like we are here. Now, this is f of x plus h, so we're going to plug that in here, and then we're going to subtract f of x, which is right here. So difference quotient, we start with f of x plus h. We subtract f of x. And I go ahead and put them in parentheses because we definitely want this subtraction to distribute all three of these terms. And then it's all divided by h. Now, what is nice about this, working with a quadratic polynomial, is that all of these terms should cancel out with terms over here. If we have an x squared, so we have x squared minus x squared, those are going to cancel. Okay, 2x minus 2x, that's going to cancel. Negative 3 minus a negative 3, so it's negative 3 plus 3, that's going to cancel. So all three of those cancel out. And so we look at what do we have left now. Well, we have 2hx, we have h squared, and we have 2h, and these are all divided by h. Now, the h on the bottom will divide into all three of those, canceling out an h from each. So canceling out this h, we have 2x. Canceling out one of these h's, h squared over h, will still leave a second h by itself. And then 2h divided by h leaves us with the 2. And so that is our answer right there. Which is answer D. So. Okay. That's more or less what you should expect on the exam question, similar to that. Okay, number 6. We're given this polynomial, or quadratic equation, I guess we could say, and we want to determine, how does it say? Determine the character of the solutions of the equation in the complex number system without solving. Now, the way we use that is using the discriminant. So when I asked you the same question on a previous test, I asked you to find the discriminant and then interpret the result. So it's asked a little bit differently than when we saw it before. So our discriminant is b squared minus 4ac, and if it's greater than 0, we have 2 real solutions. If it equals 0, we have one real, or one repeated real solution. And if it's less than 0, we have 2 complex, 0 real solutions. Oops. If you're what do you mean? Like if you're taking it in person? If you're taking it in person, there'll be someone watching you. I mean, you'll be supervised at least. I mean, regardless, in person or online, I think that's the plan. Oh, you know what? And that's an excellent question. No, we won't. Honestly, I'm not sure, August. It may be set up where we don't have to. I haven't looked at how the exam is formatted for Canvas. You may need to upload some answers. For like, I think a lot of them are going to be like multiple choice, but you know, you can still send me your work. That way, if you miss the multiple choice, you can get partial credit. And Brock, going back to your question, yeah, this is absolutely factorable. We can definitely solve this. We can actually figure out which one it's going to be based on that. Normally, when I ask this question, I give you something that cannot be factored. That way, it forces you to use the discriminant. But apparently, that's not what we're doing on this review. I don't know if I would anticipate that for the exam. I would be careful not to put too much credence into that, but you can definitely try to solve it and see what it comes out to be. Even with the quadratic formula, you'll be able to figure it out. But yeah, if we just use the discriminant b squared minus 4ac, b is 4, a is 1, c is 4. So we get 16 minus 16, so we get a result of 0, which means we have one repeated real solution. Is that how it's given on the exam? It just says one real solution. but that is sufficient. So this is answer A. Okay. I don't know. Can you... Because what happens is if you turn on certain modes like scientific, it gives you all the answers in scientific notation, which is probably not helpful. Unless you can quickly change it. Yeah, I'm not familiar enough with the 30s to... Yeah, that's scientific notation. So you probably don't want that one. We just want normal numbers, so... See which one gives you normal numbers, and that'll be fine. Okay, now 7, we had a similar question to this on our exam that we just took 2 weeks ago, that I just graded. But I asked it a little bit differently than this one is presented. Instead of giving you the 0, I gave you the binomial. That was one of the factors. This one basically is the same question, but they asked us to find all the zeros rather than the actual binomials, which is really the same process, but it means we have to pay a little more attention to our signs. So if our 0 is -4, that means we'll use -4 in synthetic division. 1, -2, -11, 52. Now this should give us a 0 right here. What we're interested in is what's next to the 0 to help us find the other solutions. Okay, so we go through synthetic division, bring down the 1, multiply, add, multiply, add, and multiply. It does come out to be 0. So that means our other solution is or other factor, so x squared minus 6x plus 13 is equal to 0. Now, this is not factorable. We need to solve it with the quadratic formula. Or we could use completing the square if we prefer, which honestly takes a little more experience to get used to that one. But if we put that into the quadratic formula, b is -6, so negative b turns into a positive 6. B squared would be -6 squared, which is positive 36. A is 1, C is 13. Sure, we can do that. I still have 8 and 9, before 15. But yeah, we'll do 8, 9, and then 11, and then 15, and then I don't know if we have time for the other two that August has for, but try to fit them in. I mean, I can just keep going. I mean, we don't have to stop right at end time if some of you want to stick around for the rest of it. But I think that's a good way to do it. Yeah. It's my office hours, so. Okay, so continuing here, under the radical, that would be 36 minus, this would be 52 once we multiply those together. 36 minus 52, that is a negative 16. And what is the square root of negative 16? For I. It's imaginary because we have a square root of a negative, but normally the square root of 16 is 4 anyway. So it's imaginary with a 4 on it. And then we can just take our 2 and then divide that into both of those numbers. So x is 3 plus or minus 2i. You'll notice on the review, it lists them separately. One is 3 plus 2i and the other is 3 minus 2i, but I think everyone's okay with that adjustment. Sorry. Here we want to find the domain. Since we have a rational expression, how do we go about finding the domain here? It's not y. Is the denominator, yes. Okay, well, how can we factor that then? Well, we have an x in common to both of these terms, so we would like to factor that out. X squared divided by x leaves x. 64x divided by x is 64. Okay, and then we get from there two solutions. We get x equals 0 and x equals 64. The answer that the book or that the exam is trying to get you to solve is x squared minus 64 without the x, which gives us two answers, 8 and negative 8. We don't want to fall for that trap, though. The x is there, so we can factor out the common factor. Now, 0 and 64 are not the domain. Instead, we say the domain is all real numbers except 0 and 64, or we just simply say x not equal to 0 or 64. And if you look at the answers on the review, it has the not equal notation, so that's what it ends up as. Okay. Okay, so on 9, it wants us to look at this rational function and determine which is not an asymptote. This is similar to a question that we had on the most recent exam. Now, what I would suggest is go ahead and find the vertical asymptotes and the horizontal asymptotes and see where we lie. This should actually tell us which one's not there. Now, vertical, remember we set the denominator equal to 0. So it's x squared equals 1, so it'll be x equals plus or minus square root of 1. So it's x equals 1 and x equals negative 1. So those are asymptotes, we know that. Horizontal, the degree of the numerator is 1 and the degree of the denominator is 2. So that tells us that since m is less than n, y equals 0 is the horizontal asymptote. So far we've determined that x equals 1, x equals negative 1, and y equals 0 are all asymptotes. If we look at the multiple choices here, that's 3 of our 4 answers. So the fourth answer that's not here, that's the one that we should pick. So when we say, okay, A is x equals 1, B, x equals negative 1, C, y equals x plus 8, and then D, y equals 0. When we look at the answer provided that way, we know 1 is valid, we know negative 1 is valid, and we know 0 is valid, so the only one left over with the process of elimination is C. Does that make sense? Good. Good. All right. 11. Let's see. 2 to the 5 plus 3x equals 1 over 16. Let's see. Solve 11 with the use of a calculator. Okay. Now this one we actually don't even need a calculator to solve. Make sure I'm on screen. Okay. We don't actually need a calculator to solve this, but we can use a calculator if we want. So two methods. One, we could say, well, on the left-hand side we have base 2. Can we write 1 over 16 as a base of 2 itself? And the answer is yes. We know 16 is 2 to the 4th power, and we can figure that out if we don't know for sure. But 16 is 2 to the 4th power, but because it's 1 over 16, 2 to the negative 4. From here, we can get rid of the base and say 5 plus 3x equals negative 4. We can subtract the 5. The 3x is negative 9, and then divide by 3, so x is negative 3. That's one way that we can do it without a calculator. Well, probably the only way we can do it without a calculator is to get both sides of the same base. We can't always do that, though. The other approach that we looked at on Monday is to take the logarithm of both sides and then once this is inside of a logarithm, we can take our exponent and move it out as a coefficient because of our properties. And so we can say 5 plus 3x is equal to log of 1 over 16 divided by log of 2. So log of 1 over 16 divided by log 2 comes out to be negative 4. Which is great, because if we get 5 plus 3x equals negative 4, then we go right back to that step. And we get the same answer, negative 3. So there are a couple of different ways we can use to solve that. Neither are terribly long, but it just depends on what you prefer at that point. I think this is the easiest way to make this a power of 2. But if you forget how to do that, the other way certainly works. This particular method is actually a little bit more flexible overall because it applies also to expressions that cannot be solved like this. This is not something that works universally. This is. Okay, let's see, then we said, was 15 and 16 was next? No, 15 and then 17 and 18. Okay, we're almost there. I'm getting hand cramps or something, I don't know, it's weird. Okay. Now in 15, when it says solve the equation in the complex number system, all that really means is we need to use the quadratic formula to solve this. We just have to solve this equation, and since it's not factorable, there's no factors of 2 that add up to a positive 1. It's not factorable, so we have to use the quadratic formula instead. Okay, so A is 1, B is 1, C is 2. Pretty straightforward. So minus 1, B squared is 1, A is 1, C is 2, and then 2 times A is 2. So we get X is negative 1 plus or minus. This is 1 minus 8, so it's a negative 7 under the radical. And the only other thing that we can do here is we can change the square root of negative 7. Because it's negative, that means the answer is imaginary. So we can write that as negative 1 plus or minus I square root of 7 divided by 2. Now, if you look at the answers that the exam gave, it actually wrote them separately, and it said negative 1/2 plus square root of 7 over 2 times I. That's a 7, sorry. And then negative 1/2 minus square root of 7 over 2. I did it again. Times I. So what they did in the answers here for this review is they split this up into 2 terms, negative 1 over 2 and then square root of I squared of 7 over 2. Instead of writing I times the square root of 7, they put I at the end. So it's not a huge leap, I think, but we just have to make sure we're making that. No, it's fine, Medicine. I'm just wrapping up the other questions that we had, and if you want to come back and look at it after, that's fine. You know, we're an hour and 24 minutes into the stream now, so that's about where you wouldn't pick up. Okay. So this one, we have a log graph, which looks something like this. And we have 4 answers. A, y equals log of x minus 3. B, y equals 3 minus log x. C, y equals log of x minus 3 in parentheses, and then D, y equals log of 3 minus x. So we have to figure out which of these is correct for this graph. And I wanted to list the answers because that's really going to inform us of our options here. Think about where the anchor point for log functions is, and that, remember that our anchor point is actually here at 0, 1, or sorry, 1, 0. Right 1, up 0. So we think about, okay, where has the graph been moved from this anchor point location? Well, it's been moved down presumably it's been moved down 3 based on what we're seeing in these answers. So we look at our answers and see which of those really reflects that change of moving it down 3 units, and that is A. That's the graph of log x shifted down 3 units. Now, it's important to notice the difference between A and C. This has it in parentheses, this is separate, so when we see log x here, the minus 3 is not connected to the x, it's separate from the logarithm. So the minus 3 is our vertical shift down 3. Whereas here, this is actually a horizontal shift because they have the parentheses there. So it's important we make note of that when we see that. Alright, and then 18. Skip. We did not cover 18. That's from 6.1 or 6.2. Okay. Let me show you what I have for you, and I'll upload this to class, or up to Canvas after. This is my key that I gave, or I think it was last fall. And so what I've done is for each of these problems I've written out my solutions and tried to be as descriptive as possible, and you know, if there's anything that we didn't go over that you still want to see, take a look at this. I'll upload it to our files as the review key, and I mean, obviously we don't worry about 4. But then it has all the results there that we didn't look at, in case there's anything else you're curious about. That's correct, Brock. Log x minus 3 is the same thing as negative 3 plus log x. Yeah. Anyway, I'll be sure to upload this PDF to our class. I don't know why this page is not blue, but you know, there it is. But yeah, this goes through all the problems. Anyway, I'm just scrolling at this point. Well, you all, good luck on the final. I was just thinking this morning, it's the last time I have to get up at 8 a.m. for an 8 a.m. class until, well, January. So, I'm thankful for that. I get to sleep in a little bit more. It's going to be crazy grading all this stuff, but I hope you bear with me. I'll try to get it as fast as possible. And I'll be sure to update y'all with what I learn about the proctoring for online, and I'll make sure I give you an announcement, hopefully today or tomorrow, just before people start taking the final on Friday. Yes. Yeah, so if you still have questions, feel free to email me. I hope you all have enjoyed this semester, or at least found it tolerable as far as math classes go. It's not what I have preferred. I would have preferred to be teaching in the classroom, and I imagine a lot of you would have preferred the same. But things are looking up as far as vaccines and stuff. So hopefully we'll get something more or less normal in our lives soon. So I think August, of all people, I think you'll be fine. Just prepare like you normally do, and I think you'll be okay. All right. Anything else? Yeah. Y'all have a good rest of the semester. Good luck on your exams, not just mine, but all your other ones also, of course. And it's been good having y'all in class. I appreciate y'all sticking through it. In light of all the circumstances we're dealing with, but yeah, y'all have a good rest of the year, and come back and see me in another class if you feel like it. Statistics, pre-cal, something else. I don't know, whatever. All right, y'all. Take care. Bye.